So today we're going to dive into our second lesson here on light and look specifically at color. So let's look at our objectives for today. The first is how can we predict the effect of combining different colors of light? We sometimes refer to that as color addition. And then we're going to look at how pigments work. Pigments is what give things their color, but how are they actually used? What's the physics behind that? This is sometimes known as color subtraction. All right, so first, we've talked a little bit about the electromagnetic spectrum. We know that a very small range of frequencies and wavelengths are visible light, and that light, sometimes referred to as white light, is actually a combination of all of the colors. And when we have white light, objects that are white appear white when they're put in that white light. Now that's a lot of whites, but that statement will make more sense as we start to look through, work through the lesson and look at how colors mix and particularly how pigments work. Now, a prism is a glass or plastic device that as the light travels through it, due to something called refraction, and we'll get to that in a future lesson here, it causes the light waves or rays to spread out, to bend at different angles based on their color or wavelength. So a prism often is what we use to take white light and separate it into its colors. Now you probably maybe played around with a prism in the past, or if you're outdoors and sometimes see light shining through droplets of water, you can see the rainbow colors. The water droplet itself is kind of acting as a prism to separate the light into its colors. So white light is made up of all the colors, and the process is reversible, right? If we were to shine all those colors into the prism, they would recombine back together and form white light. So the key takeaway here is that white light is made up of all colors. Darkness, or black, if you want to think of that, is the absence of any colors. All right, now let's first talk about color by addition of light. So the primary colors, red, green, and blue, can be used to mix in different ratios and produce any possible color. We call these additive primary colors because basically any color of light can be made from red, green, and blue. Now in the older TV sets, if you looked on the back of them, they often had inputs for red, green, and blue that would come from maybe a DVD player or your cable box or something like that. Nowadays, not so common. We use, HDMI interfaces and things like that. But they use that because within the TV set, it still is, the colors are still produced by different combinations of red, green, and blue light. So what are the colors that can be produced by some of the simple combinations of red, green, and blue? Well, if you combine all three of those, you get white light. Red, green, and blue produces white. And then we have some secondary colors, magenta, cyan, and yellow. And these are the result of combining two of the primary colors. So let's look at this little diagram here. Green and red produce yellow. Red and blue produce magenta, and green and blue produce cyan. Now, let's look at a couple cases of how we actually perceive colors, why things look a certain color, and we're going to look at color by reflection. So the color of an object that we see when light shines on it and then reflects is dependent on a couple things. First, the wavelengths present in the light that illuminate. Okay, so in other words, what color is the light, or what colors are included in the light that is shining on it? The second criteria is what wavelengths are going to be absorbed by the object. Okay, so an object based on its pigments, will either reflect certain colors or absorb those colors. And then, of course, the third one is which of those colors will be reflected. Okay, so three things: the wavelengths or colors present in the light that's shining on it, which colors will then be absorbed, and which colors will then be reflected. And which colors are absorbed and which ones are reflected depend on the pigments contained in that color. And we'll talk about pigments in just a minute. So let's look at some examples. If we have an object that is white, it will reflect all colors. So if we shine white light on it, it appears white. If we shine blue light on it, it appears blue. Okay, if we yellow, it observes yellow, because whatever light or colors we shine on it, it's going to reflect all of those. Okay, black light, or black objects rather, absorb all light. So it doesn't matter what colors we shine on it, what colors we shine on it, none of them will be reflected. They will all be absorbed. And so if there's no reflected light, the absence of light is black. So pigments or dyes absorb certain colors and reflect others. So for example, if we have a white light on a red object, the pigment is going to absorb green and blue. Remember, white light is made up of red, green, and blue. So in order for an object to appear red, it's going to absorb the green and blue and only reflect the red. So that's the job of a pigment. In order to make an object appear red is to reflect red, but absorb all the other colors. So if we shine a white light on it, we get red, okay? If we shine a blue light on a red object, what do you think will happen? Well, remember, the red pigment is going to absorb the blue, and if the light only contains blue, it's going to appear black because there is no red to reflect. All right, so what are these pigments? We have two sets. The first are primary, and primary pigments absorb one primary color. So the names for them are actually the secondary colors, but we call them primary because they absorb a single primary color. So yellow, think about yellow. It's made up of red and green, so it has to absorb blue. Cyan is made up of green and blue. It has to absorb red. And magenta is made up of blue and red, so it has to absorb green, right? If we keep these three color circles in front of us here, we can figure out ourselves, right, which colors it would have to absorb. The secondary pigments absorb two primary colors. So if a pigment is going to appear red, that means it has to absorb green and blue. If a pigment appears green, it has to absorb red and blue. And if a pigment appears blue, it has to absorb red and green. Okay, so basically the opposite colors on our color circle are the ones that it will absorb. Now let's talk about color by transmission, right? Everything we talked about so far is what happens when you shine a light on it and it either absorbs or reflects that light. The color of a transparent object depends on the color of the light it transmits. In other words, what light colors does it allow to pass through? So let's say we have some blue glass. In other words, when light shines through the glass, it appears to be blue. Well, what that means, right, is that the blue wavelengths are allowed to pass through, but the glass is going to absorb all the other colors. So it's going to have to contain pigments, right, that absorb red and green. So the glass appears blue because it transmits blue light and absorbs the other colors. So what type of pigment would we need to put in the glass? Well, the glass would need a secondary pigment that absorbs red and green. Now, ordinary window glass is colorless, right? When we see light shining through it, we are able to see all the colors and they look accurate, whether we're looking through the window glass or just looking directly at the object, because it allows all frequencies of light to pass through. In other words, it contains no pigments. It's not going to absorb any of the colors. All right, so that's it. A short lesson, but important concepts, particularly about how pigments work. Remember, pigments absorb certain light, and then the remaining colors will be reflected. So we know how to predict the effect of combining lights or color addition, and we know how to describe how pigments work, sometimes known as color subtraction, because we're subtracting out the colors that they absorb. All right, that's it.